Good morning, everyone. Today is the additional linear algebra class, basically solving the example problems based on the request of participants. So here are the formulas and different theorems and multiplications and properties you need to remember, and also the definition. Determinant is a scalar value associated with square matrix. We all recalled this in previous session. Basically, determinant is A, B, semicolon means it is separated by another row. That's why it's AD minus BC. This is the area of parallelogram, as you can see here. This is the representation of determinant. And 3 cross 3 is the Laplace expansion along with any row or column. This is the main Laplace formula. Ij represents row and column numbers. And the geometric interpretation, as you can see here, 2 cross 2 determinant is area of parallelogram formed by row vectors, and 3 cross 3 determinant represents volume of the parallel pipe. Sign indicates orientation, positive or negative. Determinant A is equal to 0, which is matrix is singular, which means it contains no inverse. When determinant is not equal to 0, matrix is non-singular, it is invertible. Here you can see the properties of determinants. Please remember this property. Determinant AB is equal to determinant A into B. Determinant A inverse means 1 divided by determinant A. This is the factor theorem for this. Please remember this formula. No need of derivation or anything. Only for basic purposes you can just identify it. We'll solve the problems based on all these concepts. Okay. These are also main important formulas. This is the example for multiplication of determinants. As you can see here, it is formula comes this. Here K means a new determinant or new matrix.
Ashwin. So
Yes, sir.
the determinant itself is another matrix, is it? Okay.
Uh, no, it's like matrix and determinant are different, sir. This
So
determinant
determinant
means
is a
it.
scalar value, you're saying, right?
Yeah.
So what do you
Area.
mean by product of two determinants?
What do you mean? Product of two determinants means we are multiplying and we are multiplying to derive same matrix multiplication and deriving some formula to actually
Oh, so
represent what it represents.
determinant is a single numerical value or what is it?
Determinant is a collection of values, sir. Right? It's row and column multiplication, as you can see here.
Yeah, so it's a collection of values, but
Yeah.
that is also represented as a matrix or it's not represented as a matrix?
It can be represented by matrix. Here, some calculation actually involves converting the determinant to matrices. It's just a scalar value.
Hmm. Okay.
Here are the matrices, type of matrices, as we recall from previous session. This is the A transpose. This one is A transpose, AJ. Matrix operation, as you can see here. 3 plus 3 is vectors.
Now, can you slow down, please? Can you explain this? Hmm.
Which one, sir?
This diagram, can you explain what is this?
This is the 3 cross 3 matrix representing some values. It's given in decimal form. We can convert it to fractions and all. This is the vectors. This
Mm,
is the multiplication A x equal to B.
no, just go back 1 minute. A
Okay.
x means the left hand side is A, is it?
Yeah, left hand side. This is A.
Hmm. And right hand side
This
is
is
a one dimension matrix, is it?
yeah. The condition is it should be number of rows must equal to number of columns of the next matrix. Then only we can multiply two matrices. If not, we can't do multiplication or any operation mentioned here.
Okay. Okay. So number of columns, huh? Number of columns.
Yeah, number of columns must be equal to number of rows of second matrix.
Hmm. So n should be same. Then you will get m into p. Okay.
Yes. As
Okay.
you can see here.
Hmm. Okay.
This is the rank of matrix. These are the various different methods. Based on this, we will solve problems. These are just a representation of the rank of the matrix. This is just a matrix inverse. These are the various different methods: adjoint method, Gauss-Jordan method, and partition method.
No,
These are
method to
just a
do what? Method for what?
to find matrix inverse.
To find matrix inverse. Okay.
Yes. Various different methods involved.
Hmm.
These are just a Cramer's rule. Uh, this is the solved example x minus y x minus. As you can see here, take the matrix of this. Take the matrix and solve these determinants. We will get these values. Uh, 3 and equations. If we find determinant of this, we can solve the problems only when those determinant is not equal to 0. So this transpose to Cramer's law. The consistency of the linear system. This is the Rose-Capel theorem for system analysis. It represents a system A is equal to B is consistent if rank A is equal to rank A of B. These matrices it should be equal. When it's equal, a number of n unknowns, unique solution. When rank A is equal to rank AB but less than n, infinite solution. And when case 3 not equal but there is no solution. As you can see here, this is just an example. These are the linear transformations. This is the linear transformation y is the orthogonal properties. A inverse is equal to A transpose. Determinant of A is equal to 1, which I mean plus or minus 1. It preserves dot product. Dot product means it only involves scalar quantity. Cross product means it involves only direction. Preserves length means mod of AU is equal to U. This proper A is removed. Preserves angles between vectors. And these are the just the properties. So this is the linear dependence of vectors. By the way, just linear algebra how is related to vectors. As you can see here, this is the dependence dependence graph and some conditions to conditions is also some represent conditions also. These are the properties also. These are the conditions. Moving on to eigenvalues. You can see the properties and all, how to find the eigenvalues, eigenvectors. This is the representation.
Tell me what is an
So
eigenvalue? If you want to explain in simple analogy, what is eigenvalue?
eigenvalue means
Eigenvalue
it's
refers to a matrix, is it?
yes, yes, yes.
What is eigenvalue?
It's the it's a square matrix of A. It's the scalar quantity such that A is equal to lambda V, as we from as from previous call we we learned. We based on this we'll also solve this problem. So can further understand will happen. Is that okay?
Mm, okay, proceed. Mm.
Then these are the properties of eigenvalues. Please remember these formulas and conditions. Also, diagonalization matrices, Hamilton theorem. These are just formulas and all. No need to prove any derivation and all. We'll solve problems. From that, we can understand this. Same goes for these and all. These are the conditions. Okay, let's go solve some problems. These are the formulas. Okay, so
How did
this
you how did you
every
draw this? Was it using latex or how did you draw this?
this done in latex for simple explanation and also.
You made this in latex?
Yeah, yes, yes.
Oh, very good. Mm. Yeah.
Okay. So first problem is expand the following determinant using Laplace expansion. As you can see here, this is the determinant symbol. Please remember A, B, C, A1, B1, C1, A2, B2, C2. Step by step solution is expand the R1 by first row. Like you see here, like this one, see here, A. You have to replace it here. Then eliminate those columns, first row and first column. Then multiply this. This matrix you see, right? This matrix or formation you see, right? This is the separate determinant. You have to take that. Then after that you have to take minus, because uh, the property says that the second row or second column always represent minus transformation. That's why it's taken B, and A1 C1, A2 C2 as a separate determinant. Same goes to C. It's also separate dependent. Corresponds to this formula. This is the standard expansion. Any doubts? Okay, so no doubts, I guess. I will move on. Okay, second problem. Find the value of this determinant. So step by step solution. Expand by R2 since it has 0. Because every time if you encounter like this determinant, try to find the smallest row or column like this 0. It would be very easier to expand this determinant according to this formula. You can expand with any rows also, but it will be take more steps. It will reduce. It will actually take more time to expand this row. And you expand this, as you can see here, this second row, second column. If you eliminate, you will get some determinant. This is the column symbol. Let's expand that in real time. Okay, so this is the 0 here. Okay, let's go. First is -1. Then if we eliminate that one, not the -1, first is +1. Sorry for that. Then if we eliminate the second row and that element containing first row and second column, we will get this matrix. Let's write that. 1, 2, 3. Then goes 3, 0, 1. Then goes 0, 1, and 2. Then here it should be minus here. Sorry for that. Why? Because we are considering the second row here. The second row always is minus. Sorry for that. Then goes plus here, 0. Then if we contain that one, we'll get 0, 1, 2, 3. It is always multiplication, so that's why it's 0, 2, 3. Then goes 2, 3, 1. Then it goes to 3, 1, 2. This is the expansion. Then moving on to third row, we'll get -3. As you can see here, when you encounter -3, you have to from that row and that column element excluding that, you have to write the elements which corresponds to 0, 1, 3. Then 1, 3, 0. Then 3, 0, 2. Same goes for this 0 also. If you encounter that, it is here in the last fourth row and second column, it is here. That column you have to, that row and column you have to eliminate. Then corresponds to 0, 1, 2, 2, 3, 0, 3, 0. Any doubts so far in the expansion and all?
No, go ahead.
Okay, no doubts.
Yeah, go ahead. Go ahead.
Yes.
Yeah, go ahead, Ashwin.
Okay. Then expand by R2. Why? Because this one R2, this first 3 cross 3 minor, it is expand by R3. You'll go with this one. Same goes for R3. You have to expand it. Basically finding different solutions. This one. This you have to solve. Here you matrix you see, right? That one we have to solve here. This is the expansion of that. You consider problems like this here. Here it correspond. If you expand that, you will get this. You have to solve, basically solve these determinants. Corresponds to 91. Basically nothing. It's just expansion of this problem. Yeah, you have to remember this formula and apply that to expansion and all. As I mentioned here, this you have to this rule you have to expand here also.
Okay.
Then moving on to second problem. Okay, so this is evaluate this matrix. Same. This also evaluate. We have to solve this determinant. This one step is operate row transformation. R1 corresponds to R1 minus R2 minus R3. This is the first row operation. Let's do that. Which corresponds to R1 minus R2, which means this is row 1. 4 is this row 1. 4 minus 2. Then minus R3 means minus 7. Then minus 6, minus 5, like that. You can see this is R1, this is R2, this is R3. It's not visible. I will just zoom it. Here you can see this is first row is R1, the second row is R2, the third row is R3. Only this row will transform. Other row, it will remain as it is. 2, 6, 10, 1. Then 7, 5, 4, 6. It will remain as it is. Because why? Because we are only applying operation on this row only, first row only. Similarly, go for second row operation, which corresponds to R2 minus 3 R4. You can apply n number of row operation, but the last outcome is we have to control it to this form. Basically, to solve easily this form, we have to obtain. After that, we will get this transformation. When solving this determinant simplification, we get minus 48. Like basically, if you consider this matrix, you will get minus 4 corresponds to into minus 2, minus 20, 5, no 3, and go 7. Basically solve this determinants and all. It's a long procedure. Then go corresponds to determinant minus 48. Any doubts so far in expansion or something? No doubts? Okay, moving on to properties of determinants. Here you can see this is the given determinant. How to solve this? So here is the important property you need to refer. This is a triangular matrix. Here contains is, these are the different elements, but the diagonal elements will be there, but the upper this lower triangular matrix is there. For such matrices, determinant will be equal to A into B into C. Now, only the diagonal elements matter because this is the matrix is now upper triangular only. Lower triangular will be 0. What is upper triangular means? Only the upper triangular. This after the diagonal elements, these elements contain elements and columns, while lower triangular matrix will be 0. It's like flipping the page. This is the border, like middle one. This is the first page. This is the second page. Here, second page should be filled. This first page should be, if it is empty, it's okay. Then only we can apply this property. If we contain this row operation and all, if you apply this row operation, like let's do that real time. X plus 2 the row operation here is okay. X plus 2 minus, put the bracket, what is the R2 content here? 2x plus 3 okay. To 2x plus 3, then plus 5x plus 7. Okay. Now this first element I have solved. Like that only you have to expand this two for first row only. This row will be remains as it is. As you can see here, this row will remain as it is. Please don't confuse that. We have to apply R2 also, R3 also. Please don't confuse that. It will be a huge problem while solving the problems, and you have to.
What will be a huge problem?
Yes,
What did you say will be a huge problem?
it will. Sir, many students confuse like when applying row transformation.
Hmm.
Many students confuse like we have to apply for R2 also, we have to apply R3 also.
Okay.
That shouldn't be do here because the end by the end of the day we have to remember this formula property to make it look like this upper triangular matrix. End of the day we have to do upper triangular. This here you can see minus 6x minus 8, 3x plus 4, 10x plus 17 is the diagonal elements. We have to retain all these, but we have to zero out, nullify this. We have to contain it to 0. That's why we are applying this operation. This row 1 is translates to R1 minus R2 plus R3. Others remain as it is. After that, in another operation, you have to apply R2. R2 means this is this row, second row, this one row, this one. Then minus it from R1, like 2x, like in 2x minus 3, and 2x minus, not minus 3, 2x plus 3 minus minus is plus here, that's why plus 6x minus is plus here plus 8 comes corresponds to here. Then other ones also you get plus 8. Then other ones also here 6x minus 8. 6x plus 8. Then here also minus 7x 3 and sorry 3x. This is the operation that separate from this row. This is the separate element 3x plus 4 minus base plus 4 minus minus is plus. Just the analogy is minus of minus a is plus a plus 7x plus 9. That way we have to consider these all elements. We have to operate R2 minus R1. Then for R3 also same here. 5x minus not minus plus 7 plus R1. This transpose R minus is minus 6x minus 8 corresponds to minus x minus 1. Moving on, we have to do this and all. As you can see here, this the why we applied this minus is this property is, as you can see, this is the lower triangular matrix from these operations. You have to expand it for a little better understanding. Any doubts in expanding the row operation and all?
Proceed, Ashwin. I'm not fully understood, but you proceed.
Okay, okay,
Hmm.
okay, okay. Then this is the property we have to apply at the end. At the end, which corresponds to x minus 8. Here, what they said is solve the equation. We got x minus 8. Similarly, we can solve this problem equation from that. Okay, this corresponds that problem. This is the second problem. Prove that this is the determinant, given determinant is equal to 0. Okay, then what is the solution is split the determinant using property 5. Your property 5 is what? Yes, this is the property. Adding multiplication, multiples of one row and another. Here the different properties. Here you have to split using this. Yeah, yeah. When we split that, we'll get this. Then take ABC common from C3. column 3 and C1 and C2 to become proportional. Then in second determinant also take these elements out of this, then we get this matrix. Since C1 and C3 are identical, like this C with column 1 is identical, column 2 is identical, so that's why it is 0, hence determinant is equal to 0. For this problem solving, you have to actually remember these properties, as you can see here. Actually remember these properties. Moving on to problem number 3, this factor theorem. Put A is equal to B. Here A is equal to B. That will become identical. So that's why it become determinant is equal to 0. A minus B is a factor. Factor theorem notes is there here. Elements of a determinant and functions of x and determinant is equal to 0 and x is equal to A, then x minus A is a factor of the determinant. This property is applied here. Then determinant degree is 4 in ABC. The product is of degree 3 because A minus B, B minus C minus A. The 3 terms is there. But the determinant is degree 4 because it contains 0, 1 and 3 degree. That's why it's called degree 4. It's the symmetric factor of degree 1. So it's A plus B plus C. Then determinant is K into A minus B, B minus C minus A into A plus B plus C. This is the formula for that factor theorem formula. Then we put A is equal to 0, B is equal to 1, C is equal to 2. We will get this determinant. After that, 1 into 8 minus 2 is equal to 6. RHS side, we have to RHS side, we have to evaluate this problem, which corresponds to minus 1 into minus 1 into 2 into 3, which corresponds to 6k. Thus, 6k is equal to 6, k is equal to 1. We have to factor
Hello, Ashwin.
Yes, sir.
Yeah, is it done?
Yeah, yes, sir. There are still many problems remaining. There are explanations also.
Okay.
If yeah.
Yeah.